Kia ora everyone, and welcome to our lesson on the properties of ionic solids. So through this lesson, what you need to be able to pick up is how we can explain the properties like hardness, solubility, brittleness, conductivity, and high melting point of ionic solids based on the fact that they are a 3D lattice of negative anions and positive cations, like we talked about last time, and that there are strong electrostatic forces in between them. And that's basically what we're going to be saying about each time. So we can say the ionic solid is soluble because it is this and this and this. Okay, so the first property that I want to look at is our solubility. Now, being soluble means that it will dissolve in a particular solvent. In this case, water. Water is the major one that we look at in terms of ionic solids. Now, if we take this as our ionic lattice, our ionic solid, with our cations and our anions, sort of see the red ones as our cations, the white ones as our anions, then they are attracted to each other because your anions, your white ones, are negative and your cations are positive, and opposites attract. Now, if we take our water molecule, and this is something we'll learn about a little bit later, you see the big purple one, that's our oxygen, and we've got a couple of hydrogens there. It's a bent molecule. Now, because we have a couple of hydrogens on one side, and an oxygen on the other side, we have what we call a polar molecule. So what it means is that on the hydrogen side, there's a positive charge, and on the oxygen's side, there's a slightly negative charge. We'll explain why that is in a later lesson, but just take it on faith for now. So what happens when we have an ionic solid dissolved in water is that if I have my cation here, the negative charge of the water, the negative side, is attracted to, so we get our cation surrounded by a whole lot of negative sides of the oxygen. And if I have my anion here, it will be surrounded by all of the hydrogen side or the positive sides of my water. The attraction between the water and the ions is greater than the attraction between the ions themselves in the solid, if it is soluble. Some ionic solids are so attracted to themselves that they're not soluble. They don't they don't get pulled away by the more attractive water, and that's why ionic solids are soluble, because they've got positive and negative charges, and water is able to attract both a positive and negative charge because it's got a positive and negative end. So water is able to overcome the electrostatic attraction of the ions to the other ions, and therefore pull the ions apart. And that's why it's soluble. So ionic solids are soluble in water, generally. Ionic solids are conductive. When we look at conductivity, we're talking about electrical conductivity, not so much conductivity of heat. For something to be conductive, you need two things. You need charged particles. So if you think about a circuit, your charged particles are electrons. In ionic solids, they are the ions. Those charged particles have also need to be able to move freely. That's the second part in terms of allowing conductivity. And we'll see in the next lesson how that works with ionic solids.